All right, so now that we framed our problem, the next thing that we want to be able to do is to represent this, besides for just some scratch on the page, we want to write it up more clean and nice. And so to do that in our class, we're going to use LaTeX. And in order to actually do the calculations, we started to already get some tricky fractions and decimals there. We want to use a calculator for some of that, and for our calculator, we're going to use the Python computing language. And we can do both of those things here in our Colab notebooks or in your Jupyter notebooks locally. In a text cell, you can look closer at this in the shared notebook, but this is how I write LaTeX, and this is how we're going to write LaTeX. Now, a simple Google of a LaTeX cheat sheet and LaTeX symbols will get you a long way. You'll see that there's plenty of documentation around how to do different things in LaTeX and make different symbols. But for us right now, I want to focus on a couple: the square root and how we write equations and expressions inline, and how we center things, as well as fractions and subscripts. All of those are used here. So to start, we write a square root. This is in Colab, when we're writing, we can see these things rendered in the second screen here. So this $ slash square root curly braces 2 close curly braces $ renders as part of this line of text in the mathematical symbols, square root of 2. This is LaTeX. This is what LaTeX does. It allows you to code nice mathematical representations. All right. Now on the next line, you see that we have some expressions centered. To center expressions, we, instead of enclosing them in single $, we do double $. This first one has x sub 0 with a subscript here. The way that we write a subscript is just a underscore. So that's if you do shift and next to your 0 key, that makes an underscore. Okay, and that makes something a subscript here. So x sub 0 equals 1.5 enclosed in double $ will be centered. And then this next expression, we see that we've got a couple of other things, namely the fractions here. And we still have some additional subscripts. So x sub 1 is still the same, centered with double $. And then our fractions, we write /frac, and then in curly braces, the numerator, followed by in curly braces the denominator. That's where this 1/2 comes from. And similarly, this 2 over x sub 0, the numerator is 2, denominator is x underscore 0. There's a lot of other symbols that we'll encounter. Here's some vertical dots, that's just V dots. And if you have a more complicated or longer than one character expression in subscript, you can just enclose it in curly braces and it'll stay as the subscript. Okay, so here we have our Babylonian algorithm written in text in LaTeX in the notebook. Now the next thing that we want to do is actually compute some of these values. So if we move into a code cell, as opposed to, this was a text cell that you can see if you hold your mouse over the bottom of a cell, you'll have the option to either add a code or a text cell. This was a text cell. This is now a code cell. And right away, we can say x0 equals 1.5. And now if we look at what x sub 0 is and hold down shift and hit enter, we see that it's 1.5. So we've saved a variable called x sub 0 to 1.5, and using this thing x sub 0 is as good as saying 1.5. So there was our first guess. Now let's make our second guess, x1. So x1 will equal, and that's 1/2 times, in parentheses, x0 plus 2 over x0. Shift enter, and now if we want, we can look at what x1 is, and it looks like 1.4666. We could find a better approximation still by saying 1/2 times x1 plus 2 over x1. And let's look at that. And one more time, x3 will equal 1/2 times x2 plus 2 over x2. Oops, x3. Okay, and that's how we can make some just basic approximations and calculations using the Jupyter Notebook, as well as represent things using some LaTeX in the text cells.